Welcome to my first ever channel on YouTube and YouTube Kids. So my channel is gonna be named Rayyan's Educative. And I'll be teaching you guys the class 6 chapters of the cbse syllabus books. And if you are a student studying in the cbse syllabus and have any doubts from grade 1 to 6, you may kindly post your doubt in the comment box and your doubt will be clarified within a week. Well, you might not just learn things, you might have some fun too. So stay tuned, like and subscribe, or this monster will appear on your bed tonight.
Yo, what's up, bro?
Video will be seeing about natural numbers, whole numbers, factors, multiples, prime numbers, composite numbers, prime factorization, HCF and LCM. So all these are based on the chapter 2 mathematics book of class 6 cbse. And if you are learning this lesson and have some troubles, just watch this video. So natural numbers, let's just begin with natural numbers. So you know that I've drawn some circles on the board. No, you can't really consider them as circles. So let's just assume them as circles. So how many circles are there on the board? Let's count. Count along with me. 1, 2 and 3. So there are 3 circles on the board. We started counting from 1, right? So when we just counted this circle, we started from 1. That's, you might have a question. Why do we even see this? So yes, natural numbers means when we count objects such as circles, apples, or anything, even spacecrafts, we always count from the number 1. So it is natural to us. No, we can't change it so quickly. So scientists all around the world have named the numbers starting from 1 as natural numbers. So let's see whole numbers right now. So this is going to be much simpler as we are already familiar with natural numbers. So we know that natural numbers start from 1. Am I right? But whole numbers start from 0. So now we know that natural numbers start from 1 and whole numbers start from 0. That's all. That's the difference between natural numbers and whole numbers. So we can say that all natural numbers are whole numbers. That is, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This goes on. That's called infinity. So all these natural numbers are whole numbers. 1, 2, 3, 4, 5, 6 comes in whole numbers too. But can we say whole numbers are natural numbers? No, it's not possible. All whole numbers are not natural numbers. So 0, 1, 2 is whole numbers. And can we say that as natural numbers? Yes, 1, 2 come in natural numbers, but 0 doesn't. So whole numbers are not natural numbers. all whole numbers are not natural numbers. All natural numbers are whole numbers. So let's begin factors. So just imagine a number, my friends. Take a number, imagine a number and multiply it with another number. So you would get a product, right? So the number you imagined at first is a factor of the product. Let me be simple. So I imagine 6 and I multiply it with 3. I get the product as 18. Am I right? So now I know that 6 is a factor of 18. And not just 6, 3 is also a factor of 18. So 6 and 3 are here, so these both are factors of 18. Not just 6 and 3, it can be any other number too. 1 is a factor of all numbers. 1 is a factor of all numbers. So this 1 is a factor of all numbers and is also a factor of 18. 1 multiplied by 18 is 18. No, multiplied by 18. So 18 is also a factor of 18. So yes, 18 is also a factor of 18. So factors of 18 are 1. First you got to write 1, then the number itself, 18. Then 18 is an even number. So all the even numbers will have the factor 2. All even numbers have the factor 2. Then 3, yes. 4, no. 5, no. 6, yes. What about 7? No. 8, no. But 9, yes. So the number which you write at the last will be the half of 18. So 9 plus 9 equals to 18. So I hope you are clear with factors. Let's move on to multiples. So let's start with multiples. Now what you got to do is imagine a number. Now that you have a number in your mind, all you got to do is pause the video and multiply it with 1, 2, 3, 4, 5 until 20. Just keep going until 20. So the last number you should multiply should be 5 into 20. So now after getting the results, you have 20 products, right? So all these 20 products are the multiples of the number which you imagined. So let me just imagine the number 5. 5 is a good number. Yep. So I'm multiplying it with 1, then with 2, then with 3, then with 4, then with 5. I'm just stopping up to this because it's gonna consume a lot of time. So 5 ones are 5, 5 twos are 10, 5 threes are 15, then 5 fours are 20, then 5 fives are 25. So all these 5, 10, 15, 20 and 25 are the multiples of 5. So now I guess you know what multiple means. So thank you. Now let's move on to prime numbers and composite numbers. Let's begin with prime numbers. So to learn prime numbers, you must be very clear with factors, because prime numbers and composite numbers is all about factors. So a number which has only two factors, that would be the number 1 and the number itself, is a prime number. For example, 3. So factors of 3 are 1 and 3. That's all. Only two factors. Those two factors are 1 and 3. So 3 is a prime number. So you have a lot of prime numbers. And I just wanted you to know that the smallest prime number is 2. You know the factors of 2 are 1 and 2. So the smallest prime number is 2, and the even prime number, all even numbers would have 2 as their factor. So none of the even numbers will be a prime number except 2. So the even prime number will be 2. Other than 2, there will not be any other even prime number. So let's move on to composite numbers. So composite numbers, we know that prime numbers have two factors, that would be 1 and the number itself. But when coming to composite numbers, they have more than two factors. It could be 3, 4, 5, maybe a lot too. So give me a number 15. Okay, what are the factors of 15? One, 15, not 2, not 3, yes, 3. Then 4, no, then 5, yes. These are the factors of 15. You might ask me, as I said earlier, the last factor would be half of the number. But why not in this case? In even numbers, we could always say that the last factor would be half of the number. But while coming to odd numbers, we do not have a proof. Yes, this 5 is not the half of 15, but it is the last factor of 15 before 15. So yes, fact cleared. So composite number 15 has 4 factors. Actually, we don't need this. We just have to check if the number has more than 2 factors. If it has more than 2 factors, then it's a composite number. So now we know what is composite numbers. Many of you might have the question, where does 1 belong to? Is it a prime number or is it a composite number? We have no clue. Still, mathematicians have a very big question about this. So, for now, mathematicians have said that 1 is neither prime or composite number. So if someone asks you, is 1 a prime number or a composite number, you gotta say this. Let's now move on to a very interesting thing called HCF. So HCF, this stands for highest common factor. So you know, a number has a highest factor, that would be the number itself. But here the word common has a meaning. So highest common factor means to find the common factor which is the highest in 2 or more numbers. For example, what is the HCF of 12 and 24? So first you have to write all the factors of 24 and 12. So 24's factors would be 1, 24, 2, then would 3 come? Yes, for sure. 3, yes, 4, not 5, yes, 6, 6 4s are 24, not 7, yes, 8, then what about 9, not, what about 10, no, 11, no, 12, yes, that would be the last. And here you gotta write the factors of 12. 1, 12, 2, 3, 6. Would there be any other number in between? Yes. If you are clever enough, you would have found that. What is that? That is 4. So 4 3s are 12, 3 4s are 12. So okay. Now you have to find the common factors here. 1 would be a common factor, so we have to take and write as common factors. And then you got to write 1, then yes, 2, so 2, and 3, then 3, yes, 4, then 6, yep, that's all. So which is the highest factor here? 1, 2, 3, 4, 6. It would be 6. So the HCF of 12 and 24 would be 6. Sometimes this would be and 36 or any other number, so you gotta wait and find out which is common in all the 3 factors of 24, 12 and 36. So I hope you understand HCF very well. And this is not just it. What about higher numbers? Like 324, 700 something. It's complicated. Let's now find out how to do it. Suppose if the question is like this, find the HCF of 70, 105 and 175. You must know all the prime numbers like 2, 3, 5, 7, 11. You don't have to memorize it. Just remember it till 20 or something. Okay, now first I take the first number 70, put an L box around it, and then I gotta check if it is divisible by any of the prime numbers. Yes, it is divisible by 7. 7 into 10 is 70. Yes, so 10 is divisible by 5. 5 is also a prime number. 5 2s are 10. Then 2 is a prime number, so 2 1s are 2. So I write as 70. Then I write as 7 into 5 into 2. If you check this, you would get the answer as 70. 2 5s are 10. 10 7s are 70. Yes. Okay, now 105. 5 into 21. 5 21s are 5 20s are 100, and plus 1 is 105. 5 21s are 105. Then 3 7s, 7 3s are 21. 3 7s are 21. And 7 is a prime number. Then you put 1. 7 1s are 7. So then 105 is 5 into 3 into 7. 5 3s are 15. 15 into 7 would be 105. Okay, now 175 it would be 5 into 35. 5 35s are 175. Then 5 7s are 35. Then 7 1s are 7. So 175 equals to 75 equals to 5 into 5 into 7. 5 5s are 10. 10 7s are what? 5 5s are 25. My goodness. 5 5s are 25 into 7 would be 175. So you got to check all the common numbers here. 7 is all in the all three, so write as 7. Then 5 is on the all three. Then 5. Then what about 2? No. What about 3? No. So 7 and 5. You first got to multiply it. 7 5s are 35, and 35 is the highest common factor of all these three numbers. Yup, that's how we get the answer. Now let's find out for other things. Okay, so LCM stands for least common multiple. So 30, 60 and 90. How will you find the LCM for these three? You just got to do successive division method, but kind of in a different way. You got to write 30, 60, 90. You got to do it all together. So 2 can divide all these, and 2 is a prime number, so I take 2. 2 15s are 30, then 2 30s are 60, then 2 45s are 90. I can divide this 30 by 2, but not these two, so still I'm taking 2 and leaving this 15 as 15 cannot be divisible, is not divisible by 2. 2 15s are 30, then 2 45, I just leave it there as 45 is not divisible by 2. Now I take 5, it is a prime number. It is all these three numbers are divisible by 5 here. So 5 3s are 15, 5 3s are 15, then 5 9s are 45. all these three numbers are now divisible by the prime number 3. So 3 ones are 3, 3 ones are 3, and then 3 threes are 9. I got 1 in these two places, but I haven't got 1 here. So still 3 again. I'll leave this 1 and 1 the same as it is. Then 3 ones are 3. At this point, I get all these three numbers as 1, 1, 1. Now I got to multiply all these numbers here. That is 2 into 2 into 5 into 3 into 3. 2 twos are 4. Then 4 fives are 20. 20 into 3 would be 40 and 60. And 60 into 3 would be 180. So 180 is the least common multiple. This is where all the three meet at first. Then at second they would meet at 260. That's 180 plus 180 equals to, this is answer will be the place where they meet at second. Now there's still one topic to finish, and that's prime factorization. After this teaching, you probably don't need to know that. Actually, it's very easy to know after knowing HCF and LCM, but still, for courtesy, they would give you a number, for example 70, and ask you to give the prime factorization of it. So you just gotta do successive division method. 235s are 70, then 5 sevens are 35, and 7 ones are 7. That's all. Prime factorization of 70 is 2 into 5 into 7. That's all. You got to do successive division method, then that's all. 2 into 5, it's 10. 10 into 7, 70. That's all. Matter close. Finish.